My name is Craig.
I'm Dan.
And this is SLO Down, SLO. And so we have our awesome little rig right here. And so basically our concept was we had made a period sensor before, a pendulum sensor. And using our Hall effect sensors, we decided, oh, well, if we can find the period, we can then use two and we can actually find the velocity of a moving object using a single magnet attached to a vehicle. And so basically what our rig does is, we were originally going to have motors to actually move these, but we kind of ran out of time. We have all the motor parts, but it's just not there. And basically what would happen is the cars would go along and it would sense how fast each car is going, and if one car is going too fast or if it's going to hit the other car, it'll it'll make a sound using the speaker, and it'll also tell that the car needs to slow down because you're going to hit it in front of it. Or you're going to hit the car in front of you. Talk about build.
Build?
Yeah. Yes.
Build in what sense?
Building wide, two DAC, yeah, two ADCs.
Okay. So we initially tried to use one ADC component, just one of these modules, but we couldn't get the chip select to work properly with using two ADCs on one module, so we ended up going with two separate ones for our two Hall effect sensors. And we have a DAC right here that outputs the sound to the speaker, or outputs the signal for a speaker sound.
What's that board there?
This board?
Yeah.
This is the circuitry for converting the 5-volt levels that the Hall effect sensors output to the 3.3 volt level that the ADC's uses input. So this just knocks the voltage down.
It's basically the peak detector circuit we had from our previous project, and we just put two on the same little printed circuit board. And then, so basically what will happen is, as we demo, we'll show, well, there's a bunch of different states of possibilities of how the cars could go, because you could have like one car go by and another car, which is the most common state, and then, or the most common case. And then there's like one could catch up to it in between the distance, and there's a bunch of different things that can happen. And so we have a state machine that tracks as the cars go by, so we can figure out, so we can compute, oh, when do we need to stop this timer? Or because there's three timers that make it up. There's one for each of the cars to compute the velocities, and there's a third timer to help compute the distance between the two vehicles. And so, and then on our LCD display, we have the velocity of the first car, velocity of the second car, and then the distance between them.
These are in miles per hour, and it's scaled. We use the 50-to-1 scale. So our real car is 50 times bigger than this, about 12 feet.
Yeah.
So we scale it in the code automatically. So when you see a number on the screen, it's as if you were in a car and you saw this on your dashboard, saying that you're going this many miles per hour.
And so if you want to come in, I'll just show you the most common case. What would happen is one car would go by, and then the next car would go by, and then it'll update the speeds of each of them and the distance between them. So yeah, we'll just do another little test real fast so you can see it update. And so just go by. Cool, and that would be the most common case, so the 29 feet between them. First car was going 23 miles an hour, 32 on the second one. And now we'll show you our slow. So if I go slow on this one, really, you gotta go faster than that. So I'll just, the slow down flag is thrown basically if the distance between the two cars is small and you're going really fast. So I mean, it's to account, like, say, car lengths on the real road. So if you had, like, say, if you're going highway speeds, like 6 car lengths, that's computed into feet, and then we do that check for that. So just go really fast.
Oh, you got it.
Oh, that. You going? Stop failing. Hold on. Oh, I think it's out of sync. Do one more. Okay, good. Now, all right. Now I'll go. I'm just gonna do it.
Yeah, it's better if one person moves.
Okay, hold on. Let me just make sure it's good. Okay. Now that it's good.
You have to go closer.
Oh yeah, that's true. What? Oh, I know how to do it. Wait, hold on. It works. Trust me. Wait. Are they out of sync? Why is the feet difference going so off? I think the magnets are flipped. There we go. Yeah! Sorry, trust me, it works. It's just really hard when you have hands because hands aren't consistent, which is why we were going to make motors to begin with, but didn't quite work out. So, but yes, it does work, and it says slow on it, and it made a little beep. And sorry that took so long.
So that'll trip when you're going. You're less than 1 car length for 15 miles per hour, less than 2 for 30, less than 3 for 45, less than 4 for 60, less than 5 for 75, less than 6 for 90. So
yes.
Okay, thanks guys.